To improve the performance of the classifier, I took multiple-phased approach to focus on addressing the class imbalance, fine-tuning model hyperparameters, and leveraging ensemble learning. Class imbalance can serially affect the performance of the model, especially in binary classification tasks like this one, where one class is far less frequent than other. To tackle this, I used a random over assembler from the RMBLearn library, which resembles the datasets to balance the number of the samples in each class. This ensured that the model would not be biased towards predicting the majority class and will learn to recognize both classes equally well. Another critical step to improve the performance was hyperparameter tuning. Both the XGB boost and the random forest model were used randomized search CV, which allowed an efficient search across a range of hypergeometrics, optimizing them for the best F1 score. This step helped to fine-tune the model's internal configurations, such as the number of the trees, learning rates, math tips, and other key parameters to enhance their predicted performance. Hyperparameter tuning plays a significant role in ensuring the model generalize well to unseen data instead of simply memorizing the training set. Additionally, I use ensemble learn to future boost the performance for the model by employing the voting classifier. I combine the predictions of the multiple classifiers, random forest, XGBoost, and the logic regression ensemble method like this benefits from the Western monochrons, and where each individual model will make different errors, and the combined output of all models trained to result in more accurate predictions. In this case, the soft voting mechanism of voting classifier weighted the prediction probabilities of each model and select the final class label based on the majority prediction, improving the overall performance. To access and improve the feed of the classifier, I took several steps to evaluate its performance thoroughly. The first step was building the data into a training set and a validation set using a training test split. This allowed me to train the model on one proportion of the data while evaluating its performance on separating proportion, ensuring that the model was not overfitted to the training data. I used the F1 score as the primary evaluation metric since it balances both precision and recall, which is especially important for the imbalanced data set where simply achieving high accuracy is not enough. The F1 score helps to identify how well the model performed in terms of the both false positive and false negative, which are crucial in medical diagnostic type problems like token prediction. I also used additional tools like confusion matrix and precise recall curves to visually assess the model's performance. The confusion matrix helped me to understand how many true positive, true negatives, false positive, and false negative the model was making, providing a deeper insight into how well the model was distinguished between the two classes. The precision recall curve gave me the better sense of how the model performs in a different classification threshold, partially for the minority class, which is often the more critical aspect in such dataset. Finally, by performing hyperparameters tuning and using cross-validation, I ensure that the model's performance was stable and not reliant on the specific split of the data. Cross-validation helps to access the robustness of the model by testing it on different subset of the data, ensuring that the final model is well generalized, and not overfitted to the training data. In conclusion, improving the model's performance involving handling class imbalance, fine-tuning the model using hyperparameter optimization, and combining multiple models with ensemble learning. To access and improve the model's fit, I use the multiple evaluation techniques, including F1 score, confusion matrix, precision recall curves, and cross-validation, ensuring that the model is both accurate and generalized for new unseen data. So that is all for my video.